Welcome to this training module on AWS Compute Basics for Cloudera CDP. In this session, we will explore how Cloudera leverages AWS Elastic Compute Cloud, or EC2, to power your data lakehouse. We will cover the fundamental concepts of compute instances, how to select the right hardware for your workloads, and how to optimize costs using auto-scaling and spot instances. Let's dive in. Let's start with the core concept. What role does AWS Compute play in CDP? Fundamentally, CDP uses AWS EC2 or Elastic Compute Cloud to provision the virtual machines that execute your workloads. Unlike legacy Hadoop clusters where compute and storage were tightly coupled on the same servers, CDP separates them. Your data persists safely in Amazon S3, while the compute power is provided by EC2 instances that can be spun up or down as needed. This architecture supports two main deployment models: data hubs, which deploy clusters of EC2 instances similar to traditional infrastructure, and data services like Cloudera Data Warehouse, which leverage Kubernetes to manage compute nodes dynamically. This diagram illustrates the provisioning flow. The CDP control plane initiates the creation of resources within your AWS account. It specifically provisions EC2 instances. These instances are organized into two logical groups: data hubs for traditional clusters and data services for containerized workloads. Both compute types connect to S3 storage for reading and writing data, ensuring that your compute is ephemeral but your data is persistent. Why do we emphasize the separation of compute and storage? The primary driver is scalability. In a traditional setup, adding processing power often meant buying more disk space you didn't need. With CDP on AWS, you can scale your EC2 instances up to handle a heavy query load without moving your data. This leads to significant cost efficiency. You pay for the EC2 instances only while they are running. Once a job is finished, you can terminate the compute resources while your data remains securely stored in S3. This agility allows you to run transient workloads, spinning up a cluster for a few hours of analysis and then shutting it down immediately. Here we see the independence of the layers. On the left is the storage layer, represented by the S3 data lake, which remains constant and persistent. On the right is the compute layer. We can start with a small cluster of EC2 instances accessing that data. As demand grows, we scale to a large cluster accessing the exact same data without migration. When demand drops, we shrink back down, optimizing our spend. How do you choose the right hardware? CDP maps different cluster roles to specific AWS instance families. For master nodes running management services, general-purpose instances like the M family are standard. For worker nodes doing the heavy lifting with Spark or Impala, memory-optimized instances like the R family are recommended to handle large datasets in RAM. If your workload is purely CPU-intensive, the compute-optimized C family is ideal. Crucially, for high performance, you should use instances with local NVMe storage, denoted by a D in the name, such as R5D. This provides fast, ephemeral cache for Impala and Spark, significantly boosting query speeds. This mapping diagram guides your instance selection. Start with the cluster roles at the top. For the master node, follow the path to general-purpose M5 instances. For worker nodes, the path leads to memory-optimized R5 instances. For tasks requiring high-speed cache or scratch space, select instances with local NVMe storage, such as the R5D or i3 families, to ensure your data processing isn't bottlenecked by network storage I/O. It is important to understand how CDP deploys these instances. We have two architectures. First, data hubs deployment is VM-based. CDP provisions classic EC2 instances directly into your VPC subnets, functioning like a traditional cluster. Second, data services like data warehouse and machine learning use a containerized approach. They deploy an Amazon EKS cluster, which is AWS's managed Kubernetes service. EKS then manages the EC2 worker nodes. This allows for a compute cluster architecture where multiple data services can share the same underlying pool of EC2 nodes, reducing management overhead and cost. Visualizing the architecture, we start with the CDP environment. On the left, the data hub path leads directly to EC2 VMs, representing the classic IaaS model. On the right, the data services path goes through Amazon EKS. EKS acts as an orchestration layer, managing the underlying managed node groups of EC2 instances. This containerized approach offers greater density and flexibility for modern workloads. When should you use spot instances? Spot instances allow you to use spare AWS compute capacity at a significant discount, often up to 90%. However, AWS can reclaim them with little notice. Therefore, the when is specific. Use spot instances for fault-tolerant workloads like Spark executors in Cloudera Data Engineering. If a spot node is reclaimed, the job simply retries the task on another node. For critical components like the Spark driver or the cluster master nodes, you should always use on-demand instances to guarantee stability. CDP allows you to configure this hybrid mix easily. This decision tree helps you apply spot instances correctly. Start at workload configuration. Ask, what is the instance role? If it is critical or a master node, proceed strictly to on-demand instances. If it is a worker or executor, ask is it fault tolerant. If yes, you can safely use spot instances, leading to significant cost savings. If not, revert to on-demand to ensure reliability. Managing capacity efficiently is key. CDP provides two main auto-scaling strategies. First is load-based auto-scaling, which reacts to real-time demand. If Yarn or Kubernetes detects pending tasks due to lack of CPU or memory, it provisions more EC2 nodes automatically. Second is schedule-based auto-scaling, ideal for predictable patterns. You can configure the cluster to scale out at 8 a.m. for business analysts and scale in at 6 p.m. Additionally, for data warehousing and engineering, you can suspend the cluster entirely, bringing the node count to 0 and stopping all compute costs when no queries are running. This state diagram shows the lifecycle of an auto-scaling cluster. Starting from idle, a workload spike triggers the scaling up state. The cluster reaches running at capacity. As demand drops, low utilization triggers scaling down. If there is absolutely no activity, the cluster enters the suspended state, costing nothing. A new query will immediately trigger a scale-up event, bringing the cluster back to life. Finally, let's look at advanced hardware options. CDP now supports AWS Graviton instances, which use ARM64 architecture instead of traditional x86. Graviton instances, like the R7G family, often provide better price-performance ratios for compute-intensive workloads. This is currently available for specific services like Cloudera Data Engineering and I-Inference. To use this, you must explicitly select the ARM64 architecture when creating your cluster and choose a compatible image. This is a powerful way to modernize your infrastructure and reduce your cloud bill. This flowchart highlights the architecture selection process. When you create a cluster, you face a decision point. Select architecture. The standard path leads to Intel/AMD. The optimized path selects ARM64, enabling AWS Graviton. This unlocks the R6G and R7G instance families, leading to the ultimate goal, better price/performance for your supported workloads.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by quicktechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. These are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper. It would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go, and various technology wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.